viscosity. Viscosity is defined as a property of a fluid which offers resistance to the movement of one layer of fluid over another adjacent layer of the fluid. When two layers of a fluid, a distance dy apart, move one over the other at different velocities, say u and u plus du, as shown in the figure 1, the viscosity together with the relative velocity causes a shear stress acting between the fluid layers. The top layer causes a shear stress on the adjacent lower layer, while the lower layer causes a shear stress on the adjacent top layer. The shear stress is proportional to the rate of change of velocity with respect to tau. It is denoted by the symbol called tau. Mathematically, where mu is the constant of proportionality and known as the coefficient of dynamic viscosity or only viscosity, du by dy represents the rate of shear strain or rate of shear deformation or velocity gradient. Thus, viscosity is also defined as the shear stress required to produce unit rate of shear strain. Units of viscosity. The units of viscosity are obtained by putting the dimensions of the quantities. In MKS system, force is represented by kgf and length of meter m. In CGS system, force is represented by dyne and length by centimeter cm. And in SI system, force is represented by Newton N and length of meter m. In the above expression, N by m square is also known as Pascal, which is represented by PA. The unit of viscosity in CGS is also called poise, which is equal to the numerical conversion of the unit of viscosity from MKS unit to CGS unit is given below. Thus, for solving numerical problems, if viscosity is given in poise, it must be divided by 98.1 to get its equivalent numerical value in MKS system. Alternate method. Note 1. In SI, unit second is represented by S and not by second. 2. If viscosity is given in poise, it must be divided by 10 to get its equivalent numerical value in SI units. Sometimes a unit of viscosity as centipoise is used. Kinematic viscosity. It is defined as the ratio between the dynamic viscosity and density of fluid. It is denoted by the Greek symbol called nu. Thus, mathematically it is the units of kinematic viscosity is obtained as in MKS and SI, the unit of kinematic viscosity is meter square per second or m square per second, while in CGS units it's written as centimeter square per second. In CGS units, kinematic viscosity is also known as torque. Newton's law of viscosity. It states that the shear stress on a fluid element layer is directly proportional to the rate of shear strain. The constant of proportionality is called the coefficient of viscosity. Mathematically, it is expressed as given by the equation. Fluids which obey the above relation are known as Newtonian fluids, and the fluids which do not obey the above relation are called non-Newtonian fluids. Variation of viscosity with temperature. Temperature affects the viscosity. The viscosity of liquids decreases with the increase of temperature, while the viscosity of gases increases with the increase of temperature. This is due to the reason that the viscous forces in a fluid are due to cohesive forces and molecular momentum transfer. In liquids, the cohesive forces predominate the molecular momentum transfer, due to closely packed molecules, and with the increase in temperature, the cohesive forces decreases with the result of decreasing viscosity. But in case of gases, the cohesive forces are small and molecular momentum transfer predominates. With increase in temperature, molecular momentum transfer increases, and hence viscosity increases. The relation between viscosity and temperature for liquids and gases are: the equation A shows that with the increase of temperature, the viscosity decreases. Equation B shows with the increase of temperature, the viscosity increases.